Welcome back, everybody. We are still working on our 2.1 notes. Oh, I'm sorry, 2.2 notes. And today we're going to talk about standard quadratic function. So the standard form is this form of ax squared plus bx plus c. And that should hopefully look familiar from all the times that we've been doing factoring and all that in previous classes. So with this form, we can't just look at it and see the vertex. Instead, we have to use a process where we start with an equation. So the first equation we're going to use gives us the x value of our vertex, negative b over 2a, where b is to be right here in our standard form, and a is right here in our standard form. Once we find that value, then we plug it in for all the x's in this standard form, and that gives us the y value of our vertex. A still gives us the reflection, stretch, and shrink, or shrink. And in this case, C will be our y-intercept. And the reason why is when we need a y-intercept, we plug 0 in for x. So a times 0 squared is 0. Plug in 0 for x with the b times 0 is 0. And then we have the c. So 0 plus c is c. Remember that your axis of symmetry, or your AOS, is the same as the x value in your vertex. So your axis of symmetry and the x value of your vertex are both found from that x equals negative b over 2a. Let's try a couple. We're going to start with finding our axis of symmetry for number 1 and the x-axis of our vertex, because these, remember, are the same things. So x equals negative b. Here's b, here's a. So b is negative 6. Remember, this negative right here is from our equation, the negative b over 2a, and this negative is because our 6 is negative, over 2 times a, which is 3. Negative 6 is 6. 2 times 3 is 6, and 6 over 6 is 1. So the x value of our vertex and our axis of symmetry are both 1. Now for the y value, we have 3 times 1 squared minus 6 times 1 plus 1. 1 squared is 1, times 3 is 3. 6 times 1 is 6. 3 minus 6 is negative 3. Negative 3 plus 1 is negative 2. So our vertex is at 1, negative 2, and our axis of symmetry is at x equals 1. The other thing that we know is that our y-intercept is at positive 1. So to graph this, you can always go back and make a t-table, but I'm going to use what we know here. So I'm going to make a graph. We have 4 and 4 here. Okay, so plot my vertex first. Let's see, let's use green. So I'm going to plot my vertex at 1, -2. And then I'm going to plot my y-intercept at +1. I'm also going to go ahead and draw in that axis of symmetry at x is equal to 1. By doing that, I know that if I have 0, 1 as a point here, then I have to have the exact same point, the same distance on the other side of my axis of symmetry. So I would have 2, 1. I'm going to show that on here. So we have our intercept at 1, -2, and I have 0, 1. So this distance here is 1. So I could come on the other side of my vertex to 2, and that would also have to be a 1. Remember, because of the symmetry. And now I can sketch my graph. All right, let's try the second one. Our A is 1/2 or 0.5, and our B is -4. Our C or y-intercept is at -2. So our AOS at x equals and our vertex are both going to start with our x equals -b over 2a. -4 is +4. 2 times 1/2 is 1. 4 over 1 is 4. So the x-axis of our vertex is at +4. Then we're going to plug that +4 into our equation to find the y part of our vertex. So I'm going to go ahead and plop all of that into my calculator. I've got, let's see, 8 minus 16 minus 2, which gives me -10. So our vertex is at 4, -10. Our axis of symmetry is at x equals 4, and our y-intercept is at -2. If I make a little t-table of that, and I have 4, -10 as my vertex, and 0, -2. So this distance is 4. So if I go 4 more this way, then I would be at 8, -2. Again, because of the symmetry of our parabola. Sketching my graph. Oops. All right. Sorry about that. That's 4, 5, 6, 7, 8, 9, -4, -8, -11. All right. So I'm going to start with my vertex at 4, -10. And then my y-intercept is at 0, -2. And my other point would be at 8, -2. So here is my parabola and my axis of symmetry at x equals 4. All right. On the next page for tomorrow, we'd like you to try example 1 and example 3. Have a great night.